The same way, we need to define the variables, so we would just use, maybe let L equal the Alright, so S, not a great variable, it looks a little bit like 5, especially my S's, sorry about that, but here we go. Same thing, we have two amounts of cookies, we know that total we have 50, so L plus S equals 50. So it's the number of large plus the number of small equals 50. So L is going to be 50 minus S, or S equals 50 minus L. The number of large, you take the small from 50, or you can take the large from 50 to get small. We need to do the value now. So we've got the number plus the number is 50. Now the value would be 3 for every large, plus 2 for every small, equals not 50, 50 is the number, and some of you will accidentally place the 50 there because I think you're just looking at the problem and putting in numbers where you think they should go. But you remember this is value, so the value is 115. Now the difference between the coin problem and this one is 3 is actually dollars, 2 is actually dollars, 115 is actually dollars, so we don't have to change 115, put a couple zeros on it. I've seen a few students do that, so be careful there. It's a pretty common errors, although most of you are starting to see those. Alright, so this is good review. So let's realize we can't add L and we can't add S together because they're not like terms. They don't have the same variable parts, not the same variable. So let's substitute something we know. We can either take the L and replace it there with 50 minus S, or we can take the S and replace it with 50 minus L, and I'm going to replace the S because it looks like a 5. So, and by the way, this is what I've done in the classroom for many of you, so this is just going to look familiar. I've done this quite a few times. So 50 minus L is going to go right here. So 3L plus 2 times 50 minus L. So instead of S, we put 50 minus L there, equals 115. So that's an L, not an E. Okay, let's see, 3L. So now we have to do the algebra, is what we'll call it. The distributive property gives us 100 there. And minus 2L. And once again, don't forget to multiply the 2 times the L. Equals 115. Most of you do okay with the distributive property in isolation, but sometimes when we put it in a problem, it just looks different to you, and you might forget to do that, so don't forget it. Well, let's combine these two terms. 3L minus 2L is just L. I'm going to subtract 100 from both sides. So I hope this is still showing up. We get L equals 15. So we have 15 large cookies. And to get the small, you do 50 minus L. 50 minus 35 is 35. 50 minus 15 is 35, that's what I said. Okay, so there's 15 and 35 for a total of 50 cookies. Alright, that's very similar to a coin problem. The only difference was we didn't have to change all the values to cents, they were already all dollars. So that's a good one. Alright, let's do a container problem, which is a little bit different. And I know some of you cringe when you hear container problem, but you are getting better at them, so let's try one more of those. And by the way, this is for our first digital learning day, so if you already knew how to do these problems, you probably weren't watching, but sorry no dog. I'll put a clip of the dog in at the beginning, because since it's a snow day, or a cold day in this case with bad wind chill, most of you probably look like a clip of the dog I'm going to post when you're trying to get out of bed. A little bit tired. Alright, let's get this last problem put up. I'm going to check the screen and see how, oh, it looks like a typical math board. I guess I could clean it. I'm going to clean it a little bit just before the last problem here. Let's see. Math class. I'll let you watch. Well, have done that on the last one. It's getting better. Told you I sprayed it with WD-40 on the last one. It's starting to recover. I think that really helped. All right, last problem. This one's about containers. Once again, I'm going to abbreviate. Here's the paper you're looking at that I posted online. So the general... Oops, I'm almost doing coin problems again. The general information. You have two containers. Okay. It says they hold 300 gallons together. Okay. And then it says something like this. If the larger holds 100 more than, and hopefully 100 more than looks like plus 100. Many of you like to write 100 plus because it's in that order, but plus 100 is actually going to fit our purposes better. Larger holds 100 more than, and then it says 3 times the smaller. I really need to write smaller here, don't I? Just trying to adapt to my small basement environment here. 2 containers, they hold 300 gallons. Larger holds 100 more than 3 times the smaller. Of course, the question now is, how many gallons does each container hold? So that's where we get our variables again. I forgot to mention that on the cookie problem. But the variables are the larger container and the smaller container. So how many gallons in each? That's our question over here. So the variables are going to be L equals number of gallons in the larger. And some of you will put amount, and that's okay. And once again, we're using S. Stuck on L and S. Number of gallons in the smaller. And by smaller and larger, we mean container. So it's the number of gallons in those. All right, let's see. Together, they equal the larger. How much is in the larger plus how much is in the smaller should equal 300 gallons. Okay, and normally I wouldn't write gallons there because we're starting to write the equations. So we'll leave that off. So now we know that we could get this other relationship if we subtract S from 300. That's how many are in the larger container. Or I'm going to just write underneath it this time. S is going to be 300 minus L. So the smaller container is going to be all the gallons minus what's in the larger. The larger is going to be all the gallons, 300 minus what's in the smaller. Okay, so that's an or. We don't have to use both of those. We can use either one of those relationships to replace a variable because we can't add L to S. Oh, but we wrote this down and this is a mistake some of you make. So this isn't going to be helpful. You could do this, and I see you do it all the time, but when you substitute it in, you end up with the variables disappearing, and that's not helpful. So let's go ahead and do that and see why in this situation it doesn't help. So if you follow the coin and the cookie procedure, it's not going to work. So let's take L out and let's put 300 minus S plus S equals 300. Now there the variables dropped out. 300 does equal 300, and that's a true statement, but we don't have a variable, so we didn't get S equals. So we want to know what S equals, so we've got to look for another relationship on this one. And some of you know that it's there right away. So this is a common error. Some of you aren't sure when to do this relationship right here. Well, here's a hint. They give us a relationship in this problem, and here it is. holds 100 more than 3 times the smaller. So we need to say the larger equals 100 more than 3 times the smaller. We usually write 3s plus 100. If you want to write 100 plus 3s, you could. Here's a picture of that. Here's the smaller one. If you take 3 of those, and add 100, then you would have what we're talking about. So here's the smaller, and the larger one is 3 of the smaller ones plus 100. So we do draw that picture on the board at school. Of course, that's supposed to be a square. Anyway, you know what I mean. It doesn't have to be perfect. Just has to happen here that you go through the right steps and try to understand it. All right, so we now have L that we can take out right there. So now we'll put, instead of L, we'll put 3s plus 100. Okay. So we've got that. Here's the error I see a few people making. They forget this part of the equation. You still have to do plus s right here. All we took out was the L and put in 300 plus s, or 3s plus 100. Still plus s. Okay, and equals this 300. So all of this stayed the same. Let's pick up a different color here. Works really well on the smartboard. So we did have, we took this 3s and we just put it right here. All the rest of this stayed the same. So the 3s plus 100 went here, and the rest of it stayed the same. We're running out of room at the bottom. This one solves pretty quickly now. If you forget this s, it messes it up though, because then you just have 3s. But we have 4s over here when you combine those like terms. I'm running out of room, so I'm going to subtract 100 from both sides. Writing it above, don't let that mess you up. I'm just subtracting 100. It could go anywhere. I'm just subtracting 100 from both sides. So 4s equals 200. And when you divide by 4, does that make it on there? S equals, why am I using s's? I don't know why. Equals 50. Yeah, I know why. It stands for smaller. Could use any variable. I could have used x and y, L and n, but it's nice when they have the first letter of what you're trying to define. All right, s is the smaller. It's 50. So let's see if we have 50, 50, and 50, which is 3 times 50. And if you add on 100, so 150 plus 100, the larger must equal 250. And then together they would be 300. And this is where that 300 minus s relationship comes in handy, because this is 300 minus s. It's just not helpful at the beginning. So it can be a little bit confusing. But here's a container problem. So you use the relationship given to you instead of having to manufacture that little relationship out of information about how much they hold together and then subtracting. This one's a given bit of information, so you use that. All right, works out pretty good. I hope you did these problems ahead of me and you got basically the same thing I did. Enjoy your day off. Hopefully this was a good review. And if we have another day off, we'll go over surface area, talk a little bit about pi, circumference, and area of circles, and probably the surface area of a cylinder we need to talk about a little bit. So, all right, good luck.